a field which is a very, very critical one for the livelihood of the human being, a water. So in this session, I would be just briefly saying what is the available environment, built-up environment available at IIT Madras Research Park and its objectives and goals. And on infrastructure line, not taking very deep into all the infrastructure which are connected to the water management, water distribution, and water conservation, and how we achieved the net zero campus concept of IIT Madras Research Park. This I will be sharing with you, and we have not done anything very big innovation in implementing all these things. Whatever the provisions which has been spelled out in various green building concepts and the certification authorities like Graha, LEED and other things, we have just followed their recommendations and also the Government of India recommendation, and we have taken cue from the stalwarts like various professors and also our president of IIT Madras Research Park of IIT Madras, and we have implemented. And I would consider this as a small interaction session to share our views. So to start with, the IIT Madras Research Park is a company registered under Section 25 of the Company Act of Government of India and promoted by Indian Institute of Technology Madras with the approval of Ministry of Human Resource Development, Government of India, having its registered office in Conam Road and Taramani. It creates the main objective of the research park is it creates an interface between academia, industry for transfer of new technology by way of research findings. The campus houses various leading national and multinational companies' R&D wings. In addition to the startups and IIT Madras incubated companies, numbering at present around 120 companies. And the campus is a self-sustaining campus with all internal and external services. The objective of the research park is creating collaborative environment between industry and academia, creating a self-sustaining and technological fertile environment, and providing world-class infrastructure and R&D activities, enabling development of high-quality personnel and motivating professional growth for researchers in the companies through even continuing education in PhD programs. Now coming to the campus, the research park is housed in 11.46 acres of land with two buildings named as phase one block with the ground plus 11 with the two basements, and with a total built-up area of 4.5 lakh square feet. The phase 2 structure with a height ranging from G+6 to G+9 consisting of blocks A, B, C, D, and a multi-level car parking of G+6 stories with a built-up area of around, total built-up area of around 15.75 lakh square feet. The internal external electric supply with a 33 kV substation with a 100% backup DG supply with the synchronized through woodward panels with auto switchover along with 1 megawatt rooftop grid connected PV solar is being catered the electrical need of this block, this park, and water supply and sanitary arrangement, air conditioning works, fire protection system, lift, and other site developments, roads and paths, CCTV, rainwater harvesting arrangement, UPS, fire alarm, fire detection, water treatment plant, sewage treatment plant, effluent treatment plant, RO treatment plant, etc. are housed. As a sustaining facility, it also serves a food court with 18,000 square feet with the 800% one-time dining facility. And also to facilitate and also the cater the prime need of the R&D organization, the conferences, meeting, workshops, and seminars. We have a main state-of-art auditorium of 900 seating capacity, 200 seating capacity amphitheater with spacious free function areas, 8 conference halls, 4 numbers theme parks, and a 100-seater mini auditorium and 2 numbers exhibition halls with a state-of-art AV facilities. The campus is provided with a hard and soft landscape, including bioshading in 3rd and 6th floor of the phase 2. Now, I will come to the water management. The campus has been built with the following design parameters. That is with a 6,000 inmates capacity and also 500 visitor capacity. As per the norms, we have worked it out. The total water requirement per day will be about 341 kiloliters with a domestic usage for 75 kiloliters, flush water 60 kiloliters, HVAC 196 kiloliters, and gardening 10 KL. Out of this domestic usage and flush water both put together around 135 KLD, we are able to generate a sewage of 120 KLD, and we treat this through an STP, which generates an HTP treated water of 114 KLD. Out of this 114 KLD, we recycle this water into toilet flushing for 60 KLD, and HVAC after its treatment out of 196 KLD requirement, 44 KLD we utilize from this treated water, and we use this treated water of 10 KLD for gardening. And balance requirement of 227 KLD we procure from outside, and we function the water management. We have arrived at the net zero campus facilities fully designed to achieve the same. It could be seen from the design parameters. The campus does not discharge any effluent outside the campus. The entire sewage is treated, recycled within the campus. The campus has 360 KLD STP and 2 ETPs of 100 KLD and 300 KLD installed and operated by Saint-Gobain Research India and Pfizer respectively. With the in-house facility of 360 KLD STP plant, we were able to manage the campus, including HVAC and horticulture and firefighting requirement with a recycled water of 114 KLD, thus procuring 227 KLD raw water from outside the campus. On commissioning a 4 MLD state-of-art STP inside IIT Madras, we have entered into an MOU to purchase an additional STP treated water from IIT Madras to cater our HVAC requirement gap of 196 KLD. Thus, we have reduced the raw water procurement to just 75 KLD. We are proud to reduce the raw water intake to just 75 KLD for a population of 6,500 persons. The normal per capita allowed requirement will be around 292 KLD at the rate of 45 liters per day. So, and this we are functioning without making any reduction in the functional requirements. We have further made the following conservation measures. We have adopted a rainwater harvesting, an exclusive basement in E block, that is in phase 1. We have a -3 level basement, which has got an area of 4,200 square meters. And we can have we have made all the mandatory raw water, fire static tanks, and also the raw water sumps required for the storage and supply, and a rainwater harvesting sump inside this basement. All the terrace water is channelized to this sump, which has got a total capacity of 3,600 kiloliters. This water kept as a reserve, and in case of scarcity, which is very common in Chennai, we use this raw water for the usage of campus. This will last for a month of our requirement. The raw water is channeled through fire static tank, so that the fire tank water will not be a stale, non-usable dead stock. All the surface runoff is channelized and collected to a open rainwater harvesting pond of 40 meter by 20 meter by 6 meter to store all the runoff, surface runoff. This facilitates the groundwater result and also provides enhanced aesthetic to landscape, and in need, we will cater the irrigation for my horticulture landscape. All the mandatory provisions of Graha 3-star rating has been met with for water conservation and usage of recycled water in this campus. All water taps in wash basin and urinals are sensor operated. Wash basin taps are fitted with the pressure compensation aerators to optimize the flow, thus reducing the consumption. All biosiding plants are irrigated with a coconut pith surrounding to reduce irrigation quantity. cooling towers being operated through BMS automation, having an algorithm with the parameters for the ambient temperature, humidity, air velocity, etc., thus optimizing the HVAC water requirements. Our distribution system, water distribution system comprises of pneumatic pumping system with automatic controllers for treated water and flushing and raw water for restrooms with online chlorination facilities. An ion exchange system with a sodium chloride backwash gel to treat water for HVAC with ultra filters with automatic dosage for antifungal, anti-adhesive and pH balancing chemicals. Adequate flow meters and record of the same in BMS and continuous analysis for usage pattern to optimize the water usage. Reuse of sludge from STP as horticulture manure. With these parameters, which are not new to the present building environment in India, is being adopted in this campus and sustained as a net zero campus. I once again thank for the opportunity given for this interaction. Thank you very much.